Hey guys, I'm here just to go over an experiment that I'm playing around with. What I'm going to do is I'm going to make a cheap RC conversion for a Power Wheels. And in order to do that, I got a $5 to $10 toy that is controlled with this RC. And it's going through an Arduino logic level relay kit. And it's going to power steering, and later on it'll go through a rheostat for the throttle. But just to show you what's going on, this is a working setup. Right now, if I control this, you can see there's almost no lag. So what's going on? Right, I got some schematics here I can show you. So this is the generic power layout. I've got the 12-volt battery, which is this guy. I've got a 5-volt DC converter, which is this guy. You don't need this. You could use either a second battery, or there's other ways of getting 5 volts. That's no problem. This I found in the trash, so why not? I'm going to use it. So your 5-volt comes down, it powers your RX board, and it powers your relay board. Your 12-volt comes down to your relays, and it's going to be switched to the motor. And the motor is this guy. For my example, I've got a 12-volt DC motor with a planetary gear set, and it makes an incredible amount of torque. I'm not going to use this on my RC build, because I'm going to use a 2-inch linear actuator. You can get those off eBay for probably about $30, I think was the last price. And you don't need very much force to turn the wheels of an RC Jeep, so it should be alright. Let's see, the next schematic, that covers all your power routing, which is really kind of rough. I can show you a flow after I go over the schematics of what I got hooked up where. It's kind of a mess, but using these cheap Harbor Freight jumper cables, I can build circuits really quickly. Just as long as the connectors aren't touching, I'm good. This is my cheap donor board, the receiver. You can see I've got my negative 5 volts from the converter in, and my positive 5 volts in, and I'm only using 2 channels for this example, so that's going to be my steering left and right. So what happens is this relay board right here, it's a logic level, which means it's switched on and off with 5 volts. I need 5 volts to power it because most relays, like these ones over here, they require anywhere from 12 to 30 volts to turn on and turn off, and obviously that's way too much voltage to expect out of a little toy. So 5 volts, it should be able to do it. This toy had 4 AA batteries, so it can power itself with about 5 volts to each motor that used to be connected to it. So here are 2 of my outputs, this black and this white. Here's my other 2 outputs, the yellow and red. And this black wire right here and this black wire right here, this is my positive and this is my negative. So I soldered those wires on there just for this example. And the relay board, let me go over its inputs and outputs. You can see that I got a ground, and I've got 3 inputs for relay 1, 2, and 3. And this one right here is my VCC, which is my 5 volts in. My battery comes down, and I've got the 2 gray wires right here. That's my positive, and this one right here is my negative. And according to this schematic right here, you can see what's going on with my relays. So my 2 channels, since I told you that they're negative switched, it's got to be a negative, and the only way to get that is to use diodes. So in my example, I have diodes actually suspended in midair. I know, not very safe, but why not? They're not touching, and it's very low amperage, low voltage. Not to expect very much. So this here is basically this little diode matrix I made right here. So what we want is for relay 3 to come on no matter what you want. If you want left or right, this one has to turn on. So that's why you can see that they're both connected to line 3. This one here, your negative's going to come through, turn it on, or this direction on channel 2. It'll come on, turn on. So 3 is always going to come on. 1 and 2 will only come on when you move the thumbstick in one direction. So let me show you what I'm talking about. In one direction, in the opposite direction. There you go. So what I did is you have 12 volts coming in, negative 12 volts coming in on this relay, which is your on and off relay. So when you click it on, it combines, it switches over and brings negative into the circuit. Now your motor's running in a counterclockwise direction. And then when you hit the thumbstick in opposite direction, these two click over, reverse the polarity, and now your motor 1 and motor 2 switch over and switch their polarity. So now your motor reverses this direction. So that's your relay board. I looked all over the internet to find a very good explanation of how to use 2 relays to switch your polarity. And you can do it, but the problem is in its normal state, these are on, so your motor's always running. And I can't have that, because when you're steering a car, you know, you steer and then you're not steering. Then, you know, you go the opposite direction, then you're not. So I needed to switch on and off. So that's why I had to add the third one. The 4th relay in my board right here is not being used. No need to. These boards are pretty cheap. I bought this board for about 10 bucks. You know, you can get 8 relay boards, 2 relay boards, or 4 relay boards. And also pay attention to your switching voltage. Like I said, this is a logic level relay board, so it switches on and off with 5 volts, although it's negative 5 volts. So, pretty simple. You got channel 1, channel 2. If I wanted to add throttle, it would be basically an exact duplicate of this, so I would need 6 relays. But these two here, clicks on 3, or you move the thumbstick in the opposite direction and it clicks on 1 and 2. So it takes 3 diodes. This diode here separates out basically left and right thumbstick. So that's a very important diode. And these diodes here just make sure that the only thing that's reaching these pins is negative. Because if it's expecting an opposite voltage, you could overcurrent the board and you could blow up some components. So if it's looking for a negative, we're only going to give it a negative 5 volts. So if you guys have any questions or comments, I'd like to hear them, because this here is just a cheap little experiment, but it's working. It's going to work really good. So instead of using these motor leads coming off this relay, I'm going to in turn put on a 2-inch linear actuator, and it'll steer my Jeep. So maybe in the future I'll go with a throttle, but throttle and a rheostat just seems like a bit much for right now. So anyway guys, thanks for watching. I appreciate it. And like I said, give me any comments you want. I'd love to hear them. Any suggestions. I'm going to try and implement them in my circuits. Thanks.